So the first panelist, whom it's my pleasure to introduce, is Fabian Hoffman. He's currently a research assistant at the Berlin office of the International Institute for Strategic Studies. His research focuses on missile technology and nuclear strategy. He's going to talk to us about some of the conceptual challenges that arise when one thinks about non-nuclear strategic weapons. Over to you, Fabian.
Thank you very much. In case you can hear me well, I would quickly start my presentation. Share my screen. And if you could give me an audiovisual signal that you can see it well, then I will start. Okay, perfect. All right, so, well, good afternoon to everyone, and I'm really delighted to speak here today on such a great panel, and it was also really interesting to listen to the previous speakers. And today I want to present some of my research on non-nuclear strategic weapons, and in particular a paper that I've been working on called Strategic Air Power Redux, Non-Nuclear Strategic Weapons and Contemporary Warfare. So if you look at non-nuclear strategic weapons and the literature, I think right now there's a clear recognition that non-nuclear strategic weapons, they affect strategic stability, often in a negative way. More generally, I think there's growing evidence of the importance of the non-nuclear nuclear nexus in nuclear weapons policy. But at the same time, I really think scholarly engagement with the subject remains somewhat limited. And first, that is recognizable in the fact that comprehensive conceptual engagement with non-nuclear strategic weapons is virtually non-existent, which creates blurry conceptual boundaries that exacerbates rigorous analysis. Second, thorough empirical engagement with non-nuclear strategic weapons remains the exception, and this lack of extensive empirical analysis often leads to speculation and runs counter to well-grounded theory building. I think it's problematic because non-nuclear strategic weapons, and in particular conventional precision strike capabilities, that will likely continue to proliferate in the coming years and decades, rendering them increasingly impactful on the international stage, and also with regard to strategic stability and broader nuclear weapons policy. So I really think that comprehensive empirical and conceptual engagement with the weapons category is desperately needed. And the purpose of this paper is to provide some analytical clarity regarding some key terms and to enhance our conceptual understanding of non-nuclear strategic weapons. At a later stage, I hope to build on the more empirical side as well. So what are non-nuclear strategic weapons? I think broadly speaking, the term refers to an advanced non-nuclear weapon system that can achieve decisive strategic outcomes in conflict. And I really think the key aspect defining these weapon systems are the strategic functions they may fulfill. So what does the term strategic mean in this context? Well, every weapon system is strategic, or it ought to be, in the Clausewitzian meaning of the term, relating to the means-end relationship between the use of armed force and political objectives. So weapon systems, they are the tools, or ideally the tools enabling the use of armed force in the pursuit of political ends. However, if we talk about nuclear weapons, the term has acquired a different meaning. So the term strategic weapon really has its origin in the interwar period between World War I and World War II. So back then, air power enthusiasts argued that the invention of the bomber has enabled a new way of defeating the enemy. Instead of meeting and defeating the enemy on the field of battle, it was now possible to engage the adversary's sources of power directly through a strategic air campaign. In this sense, the bomber offered what analysis back then referred to as independent effect and allowed combatants to affect the strategic level of warfare directly, where these sources are located, skipping the tactical and operational level of warfare. In this sense, the bomber is actually not different from a gun or even a combat knife. These weapon systems are equally strategic in nature in the sense that they can contribute to destroying the enemy's sources of power. The difference is that in order to do so, these weapons need to go through the tactical and operational level, which takes enormous time and usually comes at the cost of great bloodshed. And as you may know, the experience of World War II was largely a sobering experience for air power enthusiasts. The strategic air campaign against Germany proved largely ineffective, in particular because it took so long. and allowed German morale and industry to recover in between bombing runs. And this only changed very much at the end with the advent of the atomic weapon. And the rise of nuclear weapons in that regard, they then did not really fundamentally alter existing policy, especially not related to the use of air power. And indeed, air power strategists at the US Air Force, they simply integrated the nuclear bomb into their current thinking without reconsidering their main assumptions. So the nuclear bomb was a strategic weapon, just like its conventional counterpart, with the exception that it could impose devastation and destruction much more efficiently and effectively. So indeed, this early air atomic thinking critically influenced US Strategic Air Command's outlook on nuclear war. The idea was to quickly defeat the Soviet Union in case of an outbreak of a war through the employment of nuclear weapons. In the late 1940s and early 1950s, the idea was to disrupt the Soviet Union's war economy through nuclear bombing. And when the Soviet nuclear arsenal grew, the idea was to blunt the Soviet nuclear attack through striking first. Today, we would say that US strategy shifted from counter value to counter force. However, the idea was in each case to skip a confrontation with the Soviet Union on the tactical and operational levels of warfare to the extent possible, in favor of engaging the principal sources of its national power directly, its war industry and its most powerful weapons. As we know, there are two significant issues of strategic air power in the atomic age. First, threatening major devastation in response to anything less than existential threat of highest order lacks credibility. And second, striking the enemy first with nuclear weapons invites nuclear retaliation, thus potentially negating any political benefits that the attacker might accrue. Strategic Air Command was confronted with the first challenge immediately after World War II, and also with the second challenge later down the road from the mid-1950s onward, when the Soviet Union's nuclear arsenal started to grow. As a result, although nuclear weapons in theory constitute the ideal strategic weapons, their practical utility is limited. And I think this is really where non-nuclear strategic weapons come in. Non-nuclear strategic weapons are a new type of weapon system that is strategic in nature. In other words, similar to nuclear weapons, they can be used to attack the enemy's sources of power directly, skipping the tactical and operational levels of warfare. However, unlike nuclear weapons, well, unsurprisingly, these systems are non-nuclear in nature, which provides them with two key advantages. First, threatening their use is much more credible because they are much more usable than nuclear weapons. As a result, their employment can credibly be threatened also in limited war scenarios below the level of existential threat. And second, using these weapon systems may invite significant response, that is true, but states may still calculate that this response will take place below the nuclear threshold, thus significantly lowering the expected cost of striking first with these weapon systems. So as such, I would argue that the advent of non-nuclear strategic weapons constitutes a third iteration in the evolving thought on strategic air power theory. And again, as was when we shifted from conventional to nuclear bombs, the fundamental idea has not really changed. However, we now have access to weapon systems that are potentially as powerful as nuclear weapons, but are also much more usable. So for the first time in history, the promise of strategic air power theory may actually materialize. So let's go then back to the weapon systems themselves. For the purpose of my paper, I define the term non-nuclear strategic weapon system. I define the term non-nuclear strategic weapon as a system that may, one, credibly threaten the survivability of the adversary's forces, including its nuclear deterrent, or two, jeopardize high-value political and socioeconomic targets, threatening the state's connectivity and its ability to function normally. And given their ability to fulfill strategic functions, we have to take them into account when considering issues of strategic stability and, more broadly, nuclear weapons policy. So, in theory, both kinetic and non-kinetic weapon systems can fall under this category of non-nuclear strategic weapon. My research focuses particularly on kinetic weapon systems, so conventional precision strike capabilities. This does not mean that non-kinetic capabilities, so for example, cyber weapons, are less important. Rather, for me, for now, it has to do with the fact that cyberspace is much more secretive in nature, which makes it really difficult to find reliable and quantifiable data on the issue. So what variables are then important when differentiating non-nuclear strategic weapons from other types of advanced non-nuclear capabilities? I think this really depends on the functions you want these systems to fulfill. And as outlined above, I think the two functions that are most relevant, in my opinion, are counterforce and countervalue. So for counterforce targets, you require range, as these weapon systems may often be located relatively far inland, as well as hard target kill capability, as these targets are often hardened. So think, for example, of missile silos or command and control bunkers. Counter-value targets, on the other hand, often do not require hard target kill capability, given that they are usually located above ground and relatively soft. Long range is, however, still useful. So I think from a most parsimonious perspective, two variables are thus important, which is hard target kill capability and range. Well, the range we can usually infer with relative ease. Often manufacturers of these weapon systems, they provide information on the maximum range of their weapon systems. If not, open source intelligence can usually provide some pretty good estimations. Looking at hard target kill capability, I think things get more complicated. So there are several factors that are important that we need to consider. These include, for example, the warhead type of the weapon system, its payload, the kinetic energy transferred during the impact, as well as the accuracy of the weapon system. So this idea can be represented also in a function whereby W stands for the warhead, P for the payload, K for the kinetic energy, A for the accuracy of a certain weapon X. And what you get from that function is what I've referred to in a recent paper as the counterforce coefficient of a certain weapon system in question. What we can then do is we can plot the range and counterforce coefficient along an X and Y axis, and we can illustrate the strategic utility of different non-nuclear strategic weapons according to the counterforce and countervalue potential. So the graphic that I've put up here depicts some of the conventional precision strike capabilities that are currently deployed or soon to be deployed by NATO member states in Europe, and displays them according to their strategic utility. Please note that the locations of the different precision strike capabilities on the graph, they're not yet the result of precise calculations. Rather, they constitute estimations based on prior research conducted, including several expert interviews with missile and board engineers, taking into account the variables outlined above. And then nevertheless, I think the graph provides some indication of differing strategic utility of distinct conventional weapon systems. Importantly, the fact that the graph only depicts cruise missiles deployed by NATO right now does not mean that the latter are the only ones deploying such systems. In fact, there's a growing number of states, including Russia, China, South Korea, Japan, and Australia, among others, that deploy or procure systems that could potentially be classified as non-nuclear strategic weapons. In addition, I also always have to say that because otherwise, data is asked in the question, in no way do I argue that NATO should not deploy these weapon systems or that NATO weapons are particularly destabilizing. I think quite the opposite. I think NATO has a clear strategic imperative for these weapon systems, and they're actually stabilizing in some ways, especially in light of Russia's own massive buildup of missile capabilities. The key reason, however, why I chose only to depict NATO weapons in this graph is that NATO deploys a beautiful range of diverse missile capabilities, which helps to illustrate my point. And putting China, Russia, and South Korea also on there, we would just clutter it. So in a subsequent step, what we can then do is we can delineate the selection of precision strike capabilities into different categories. So category A describes the weapon systems with a high counterforce coefficient and a low range. Category B weapons differ so far that they not only have a high counterforce coefficient, but also a high range. So as a result, they may be used to engage hardened strategic targets deeper inside the enemy territory. Categories C and D include conventional weapons with a low counterforce coefficient and a short and long range respectively. And as a result, they're located in the bottom right and bottom left corners of the graph. I think this information or doing this exercise can be potentially useful because it provides insights into the different implications of these weapon systems. So, from a traditional first strike perspective, the proliferation of category A and B weapons is probably most concerning. This being said, the proliferation of category C and D weapons should probably also not be underestimated, given that these weapon systems still have counter-value potential. So finally, some of the key takeaways. So first, what I've tried to do is I try to provide some conceptual input into the debate on non-nuclear strategic weapons. I've done so by looking at this weapons category through the lens of strategic air power theory. In this regard, I think the introduction of non-nuclear strategic weapons constitutes only a third iteration in the evolving thought on strategic air power theory. And for the first time, the promise of air power theory may actually materialize. Second, I have defined non-nuclear strategic weapons as weapon systems that may fulfill strategic functions. In other words, they may be used for counterforce and counter-value purposes. And two key variables were identified in this regard: range and hard target kill capability. Third, the different types of non-nuclear strategic weapons follow different functions. As a result, the strategic implications differ as well, and overall, this demands a differentiated view of the weapons category. So at this point, thank you very much for your attention. I really look forward to your questions. If you're interested, these are two of my relatively recent publications, and they dive into some of these issues that I have outlined. Thank you very much.
Thank you very much, Fabian. Excellent presentation. The next presenter is Harry Spencer. Harry is a master's scholar at the University of Birmingham. Harry's research focuses on emerging technologies and nuclear strategy theory, including the implications of hypersonic weapons and missile defense, on which he has written a paper for British Pugwash that I commend to you all. Today, he plans to explore US and Chinese warfighting strategies and to discuss missile defense implications for the Asia-Pacific theatre. Over to you, Harry.
Okay, wonderful. Thank you very much, Peter. Just give me a few seconds and I'll bring up my slides. Again, audio, visual, can we all see those?
Yes, that's great.
Yeah, wonderful, brilliant. Okay, well, hello everyone. Thank you very much for holding out for what is indeed today's final panel for this conference. Big thanks, of course, to British Pugwash and the team at the Third Nuclear Age in Leicester for putting this together and giving all of us a chance to come and speak to you today. We're going to be talking about missile defense, and we're also going to be taking a look at the increasingly complex issues concerning military strategy and technology, and indeed escalation in the context of the Asia Pacific. So taking a look at the agenda today, if the slide wants to switch over. There we go, wonderful. So taking a look at the agenda, I'll start with a short introduction and then jump straight into some of our key topics. We'll look first at Chinese A2AD, what it is, what it attempts to achieve and how it's operationalized, and then on to US JAM-GC strategy, which is a comparative doctrine and commonly still referred to as air-sea battle. Then we move straight on to how missile defense operations fit within the context of those two competing strategies. And this is then, of course, followed with some concluding thoughts. But before we get into any of that, I think it's safe to say that for those following developments in missile defense issues for the last maybe 14 months, it's been a very turbulent 14 months. On the right there are just a few of the headlines that I'm sure many of us remember dominating discussions on what felt like a weekly basis throughout last year. And in that time, if it wasn't already, missile defense, its effectiveness, its role in all of this has become quite a hot topic, particularly as attention draws to the Pacific theatre and as developments in Beijing's missile arsenal turn some faces pale. Amongst the ambiguity, one thing we know for certain is that the outcome of a missile defense operation is dependent on a considerable number of variables than is often given credit to. So for me, one of the best ways we can analyze and dissect missile defense is to place it in a strategic context, hence today's discussion. So moving forward, today's focus will revolve around understanding the roles and implications of missile defense systems within the parameters of US and Chinese military strategy. What are they doing in the Asia Pacific? Why are they being increased numerically? And what can we expect from them in terms of effectiveness? But before all that, I want to first explore the predominant strategies employed by these two powers, starting first here with the Chinese approach to anti-access area denial. Now, this is by no means a novel concept. A2AD draws from that that kind of somewhat long tradition of active defense, which has been employed by Beijing for some decades now. It's largely the product of a big shift that happened in Chinese strategic thinking in the 1980s, away from large-scale land warfare doctrines and towards more high-intensity regional conflicts in China's immediate geography. Now, A2AD is what one might call an enabling strategy. It's highly aggressive, often quite escalatory, and often relies on shooting first as a means of seizing an immediate advantage for land forces in the opening moments of a conflict. And this all comes with essentially three main objectives or themes. The first is freedom of operations, and this translates into essentially eliminating enemy defenses and forces in the immediate short term, so as to create the ideal conditions within which the PLA can conduct whatever operations they so please. Second is to deter and defeat attempts at third-party intervention. This is widely held to be pursued with reference to the United States by keeping enemy forces at a suitable range from concentrations of friendly forces. And last is very much, or is as much rationale for A2AD as it is a product of. And it's something the Chinese have been referring to as war control. In nuclear strategy, we sometimes talk about this in terms of dominance, and it's basically the ability to set the intensity and scale of a conflict, wherever, however China so chooses, by carefully selecting the targets you attack and the extent of your strikes. This is done basically to manage a conflict in a way that's favorable to China and to allow them to terminate conflicts if operations turn against them. Now, in operation, A2AD reveals a lot about what we might expect a conflict in the Asia-Pacific to actually look like. As I mentioned, it's quite inherent to escalatory behavior, and it's multi-domain in character and would involve all aspects of the PLA's forces. That's everything from missile forces, naval and air forces, and indeed pushing into those kind of novel spaces of space and cyber warfare. As mentioned earlier, the strategy benefits hugely from striking first, and that means using missile and air forces to conduct first kinetic strikes against enemy bases and forces, whilst also using cyber and anti-satellite forces to blind and disrupt the command, communication, intelligence, surveillance, or reconnaissance assets of the enemy in question. In response to this, largely, and in response, I suppose, the threats of ballistic and cruise missile proliferation that we've seen around the world, the US developed what was formerly called air-sea battle. In about 2015 and 17, they had a name change, and this went over to the Joint Concept for Access and Maneuver in the Global Commons. Now, the DoD stresses that this doctrine isn't necessarily catered solely towards the threats in the Asia-Pacific. Indeed, to some extent, this has applications for threats in places like Iran too, where obviously a nation which deploys a number of ballistic and cruise missiles itself. So where did it come from? Well, there was a very abrupt realization from the US military that actually quite capable ballistic and cruise missile technologies were effectively getting into the wrong hands. And these actors were actually quite well placed to interfere with US military deployments in future conflicts. JANGC is really underpinned by the realization that modern US military conducts will be done in a way that relates to what we call expeditionary warfighting. That is, US forces are projected into a theater of operations through use of air and sea deployments. And this comes with a number of necessary conditions. The first is that the US military would require air and naval supremacy. The second, safe, logistically networked bases of operations, similar to those you see on that chart just there on the left. Third, resilient and reliable C4ISR. And fourth, I suppose as a product, the freedom to carry out large-scale maneuvers to influence the course of events during any conflict. The key issue here is that A2AD, by design, threatens all of the tenets that expeditionary warfighting relies upon. So how does it work? Well, JANGC is a sort of guideline, more so than a warfighting strategy. It aids policymakers to organize, equip, and deploy forces as much as it is to guide what happens on the ground. It basically understands that the future of warfare takes place, at least for the US, under contested environments. Now, this works sequentially in some ways, but effectively unfolds in three main steps. The first is surviving that initial attack, either through active defenses, such as air and missile forces, or passive defensives, such as hardening shelters or having redundant assets. Second, this is in theory followed by a comprehensive anti-satellite and cyber network counterattack. This is referred to as the blinding phase and would be used against enemy command and control and satellite assets to effectively hinder their ability to exercise battlefield management. Third, finally, and if this hadn't been done already, the US would then conduct kinetic disarming attacks against assets, bases, potential launchers, and other hubs of command and control, so as to reclaim that very precious freedom of maneuver. So the question we're left with is, where does missile defense fit within all this? What are their roles, and what is it we can expect from them? So missile defense systems are really beginning to form the central pillar of that first phase of survival for US strategy. We've now got THAAD, Patriot, ship-based Aegis, and more recently Iron Dome being deployed to the Asia Pacific as an attempt to create some sort of versatile, layered defense against what is an apparent growing ballistic and cruise missile threat. But among the many concerns is that the US appears to be relying quite substantially on these systems to mitigate the impact of that initial attack. Frankly, there is no guarantee that when push comes to shove, that any of these systems will be able to do that. There's a huge array of things that influence the outcome of a missile defense operation, and some of those you can see on that little web on the right there. But something crucial to mention is that A2AD targets the exact infrastructure that supports missile defense operations: the search and the tracking radar, the satellite communications infrastructure, launch detection systems, and battle management systems. All of these things that will be prime targets for the PLA in the opening moments of an attack, not necessarily because they're solely relevant to missile defense, but because they're important to US expeditionary warfare. These systems missile defense systems rely on very delicate networks of supporting assets to communicate and coordinate defensive efforts. And at all times, they are one jammed radar, one disabled satellite, one good cyber attack away from being completely unable to provide any support. A recent GAO report actually revealed that the MDA hasn't conducted any cyber intrusion resilience tests on any of its missile defense systems since 2017. The reality is we don't know whether these systems will be able to survive the kind of attacks we expect them to see in the field. Actual effectiveness aside, if the US needs these missile defenses to have a chance, if these bases have any real chance of providing platforms for operations in future conflicts. And the biggest risk here, perhaps, is that the US will see huge value in taking out Chinese systems before they can be used to attack US bases. Other problems for effectiveness can be numerical. China has grown its missile forces at breathtaking speed, now possessing hundreds of capable ballistic and cruise missiles with varying types of warheads and capabilities. The ability for these systems to cope with concentrated large numbers of attacks by synchronized attacks at the same time is actually unknown. The US doesn't test systems against really anything more than 2 projectiles at a time. There's also economic problems facing the US here too. At a time when budget constraints for the US military are increasing, the last thing the US wants to hear is that actually it is significantly more cost effective for the Chinese to attack than it is for the US to defend. A paper in the Asian Security Journal just last year suggested that in a large-scale use, it's about 4 times more expensive for the US Navy to defend against ballistic missiles than it is for the Chinese to launch them. So what's clear is that the uncertainty around the effectiveness and vulnerability of these missile defense systems really could, in some ways, be an Achilles heel for US strategy. The reliance and this kind of almost blind faith in some of these systems is really showing as a lot of these issues remain completely unaddressed. So my final thoughts for the presentation are as follows. The space for diplomatic resolutions to these missile issues is tight. The reason being that the mass deployment of ballistic and cruise missiles is firmly cemented in the PLA's warfighting strategy. We're no longer just asking China to reduce its ballistic and cruise missile stockpiles. What we're actually asking for is some sort of reformation or complete degradation of what has been a very complexly designed strategy. Second, and this flows into this point, is that any conversation on limiting missile defense deployments in the Pacific will probably now fall on deaf ears in Washington. Indeed, missile defenses are being increasingly relied upon to protect these bases and assets, and are becoming essential to US future projections of power. In this almost cyclical manner, the increased deployment of missile defense systems actually justifies China's acquisition of further missiles and vice versa. The third point is, regardless of the uncertainty, the US appears to be steaming ahead with theater missile defense developments and deployments with apparently very little consideration as to their impact on the broader security situation or with any regardless to their potential effectiveness. It's possible that if the time comes and these systems do need to be used, the US military might receive a very nasty surprise, and they probably will underperform. Fourth and finally, and perhaps most uncomfortably, it's been demonstrated that both of these strategies place a great deal of value in shooting first. In a sort of use it or lose it way, both parties will actually be vying to make the first move in any crisis, purely because of the value to each strategy in doing so. For me, one of the big questions here comes down to geography. The Chinese mainland is going to be on the doorstep of any conflict, and that means any effective implementation of US strategy would probably translate into strikes on the Chinese mainland. And that obviously remains the question: what does that mean for escalation? How will China respond to that? And what steps would they take in accordance with their strategy to paralyze a conflict? Well, thank you very much for listening. I hope I covered enough ground and that wasn't too fast for anyone. I very much look forward to your questions, and yeah, thank you very much.
You end on a daunting note, Harry, but you justified doing so admirably. That was another excellent presentation. Thank you. Ludovica, shall I hand over to you now to manage questions?
Yeah, sure, Peter. So we do have now just one question in the chat box from Niels. I think it's for Fabian. So Niels asks whether you could further expand upon the difference between non-nuclear strategic weapons. Would you qualify UAVs and loitering munition used in the Nagorno-Karabakh conflict as kinetic non-nuclear strategic weapons, given their decisive role? And do non-state actors already have access to non-nuclear strategic weapons? If so, have they managed to leverage their strategic functions?
Thanks, Claude. That's an excellent question. All honesty, I like the recent conflict between Armenia and Azerbaijan. Not my strong point. From what I heard, these weapon systems mostly engaged units. So I think they had more of a tactical and operational impact. So I think the actual strategic impact. So what I try to convey, a weapon system that engages the sources of national power directly, like for example, the war industry. In these cases, obviously, these states do not have the same military than China or the United States, for example. So the counterforce potential that you could leverage against them is somewhat less limited. However, so from my limited understanding of the conflict, I would say they have been used more in a tactical and operational way. This being said, I don't see a reason why UAVs or loitering munitions in general should not also be classified as kinetic non-nuclear strategic weapons. Same ballistic missiles or hypersonic glide vehicles, for example. So the category is certainly broader than just cruise missiles. Have non-nuclear strategic weapons been used by non-state actors? I would actually say so. I think what the Houthi rebels tried to do in Saudi Arabia, or actually the recent attacks against the UAE as well, they used these weapon systems in a counter-value role. So it's actually quite impressive. It's a non-state actor who has access now to with the Zulfikar ballistic missile to a medium-range ballistic missile, and then of course also the cruise missile arsenal that's been acquired with the help of Iran. And these weapon systems have been used to strike soft counter-value targets, and actually quite effectively, if I may say so. And I think it's the really interesting part about this is, like deterrence by punishment or coercion by punishment, or compellence by punishment as well. It's not new to terrorist attacks, but usually this was done through suicide bombing, and basically the Houthi rebels are now capable of doing that, of punishing their state adversaries at an extended range. So it's standoff range. I think that's really interesting. So yeah, I would say that these weapon systems have, like non-nuclear strategic weapons, have been used by non-state actors. The effectiveness, then again, that's probably difficult to figure out. I think one interesting aspect here is also that the Houthi rebels, they still show some restraint to a certain extent. So when they shoot their ballistic and cruise missiles or their non-nuclear strategic weapons, they targeted, at oil facilities, basically at industry. Well, they could potentially, they could also just shoot it straight into a huge civilian commercial area, or just the shopping street in Dubai. That would theoretically be possible, but they have not yet done so. So they show some restraint there. I think that's certainly also an interesting aspect to consider. And can certainly hope so that it stays that way. But yeah, I think I would end my remarks here.
Ludovica, if you don't have a question waiting, could I ask one?
Yeah, and then there's another one that just arrived, but please go on.
If I may butt in, taking advantage of my position.
Yeah, go on.
Fabian, you implied at one point that non-nuclear weapons, strategic weapons like precision strike missiles, for instance, could be as destructive as nuclear weapons, but even against hardened targets like missile silos. I confess that surprised me. I'm not saying you're wrong. I don't know better. I certainly don't know better, but I was surprised. I imagined that even with modern explosives, modern non-nuclear explosives, you wouldn't get as much bang as you would out of a nuclear warhead.
Oh, certainly. I mean, I did not mean it in the sense of the same explosive power. I think it's really about destruction of target. And there's absolutely no reason why a nuclear weapon, that is detonated within, or at around 200 meters away from a missile silo, should be more destructive than a cruise missile equipped with a multi-effect warhead hitting the missile silo precisely there where it is most vulnerable. So then I think the destructive effect of these weapons, or of the conventional weapon, in this case, might even be more effective. But of course, the explosive power itself certainly cannot compare.
I understand. So it's the precision that really countervails the weaker explosive power.
Yeah.
Understood. Thank you.
We do have two questions now. Both are for Harry. So the first one is from Sean, and is wondering whether you would identify the recent expansive deployments of US missile defense systems as part of a greater strategy to bolster early detection and surveillance of Chinese ballistic missiles and better protect the US mainland. That's the first one. Then the second one is from James, and it's for Harry too. Do you see a future for Iron Dome in the Asia Pacific, or do you see this as a stopgap purchase while the US sources alternative missile defenses? Asking as these technologies are also on the shopping list for UK armed forces, and their current usage in the Middle East concerns a different sort of threat than that posed by the missiles fielded by current state actors in the South China Sea.
Okay, brilliant. So first off, Sean's question regarding US deployment of ballistic missile defenses. Okay, so obviously that's kind of a two-parter. Is theatre missile defense there to aid early detection and also play a role in helping the homeland? So I can approach that in two ways. The first, regarding early detection, yeah, definitely. We also need to remember, and this ties into the second part of your question, a lot of these missile defense systems were there or are placed there predominantly with North Korea in mind. So THAAD in South Korea, and also the systems like the Aegis ship-based are deployed with mid-course and terminal interception capabilities for North Korean ballistic missiles as much as they are for Chinese. So yeah, in a way, early detection, yeah, the THAAD radar and the Aegis ship-based radar play a big role in national missile defense. But are they there specifically to protect the homeland? Yeah, it's difficult to say. If you ask the DoD, they would probably say no. But there are being efforts made to integrate things like Aegis into the Homeland Defense System. So not too long ago, I think it was 2018, the SM-3 Interceptor demonstrated an ability to hit an ICBM target. What that means it's now officially part of the Homeland Defense Network is quite difficult to say. I think more work needs to be done on that before they officially claim it's part of that network. So yeah, I think that's my answer. In a way, yes, in early detection, absolutely, but actual interception, not yet. maybe. James, I'm just going to reread your question. Do you see a future for Iron Dome in the Asia Pacific, or do you see it as a stopgap purchase while the US sources alternative missile defenses? I mean, it's a brilliant question because it could be both. In the sense that, for those that aren't already aware, the United States military bought and deployed Iron Dome in Guam, predominantly as a short-range air defense against cruise missiles. This came quite timely. This decision came quite timely after we saw the performance of Iron Dome in the Israel exchange at the start of last year. Is it a stopgap? Yeah, probably. We know that the US Army has expressed interest in a short-range air defense actually modeled very closely on Iron Dome. We're not too sure on the progress on that, or at least I personally am not. Whether that system matures and then ends up replacing Iron Dome on Guam, or it will complement it, or it will have no place alongside it, we don't know. But yeah, it possibly both, I think. Brilliant question. And if am I taking liberties and then going straight for Neil's question there, or? Yes, I'm gonna go, yeah, okay, no worries. Neil's your question is obviously, didn't really grasp why the US and China would have incentives to strike first. Could you elaborate? I can. So if we start with the China aspects of that question, A2AD relies on, I won't say it relies on seizing the initiative, but one of the best ways to conceptualize A2AD is understanding it as an umbrella, right? It enables force operations within the first and second island chains by attacking assets that may end up being a problem later on. And this is why the US gets worried about them, right? So the idea, at least as a Chinese strategist, is you use your ballistic missiles, your airstrikes, your naval assets and cyber and space to effectively attack bases, aircraft on, parked at airfields, ships in dock, and you take them out before they can be used to hinder any operations. Not entirely sure how controversial it is to use it as a case study, but I will. One of the ideas being circulated in conversations about this is how the Chinese would use this if they were to forcibly invade Taiwan, right? So in a contingency where they conduct operations against Taiwan, A2AD plays a brilliant role because you basically eliminate US assets before they can be used, and then anything that tries to come in from home bases is basically kept at arm's length, right? That's why you would probably shoot first to the Chinese. The American incentive to shoot first is basically to stop that happening, right? If your strategy or your doctrine anticipates that Asia Pacific as being quite a hostile environment, one of the smart things to do is go, okay, fine, but we're gonna launch airstrikes against your systems before you can use them. We'll take out your satellites before we can use them. We'll use electronic warfare and cyber warfare assets to scramble your communications and make it very difficult to carry out those conducted attacks. And that's why I wanted to hammer home the point that it's a very escalatory, both of these strategies are very escalatory in the sense that they both have so much to gain from taking that first step. But brilliant question. Yeah, very good question. It's a big point of contention for the two strategies.
Can I just, I would suggest to move on to Louis' talk and then having a general Q&A later so that we have half an hour of, general questions and answers and remarks.
Yeah.
So please go on. Well, Peter. So.
Yes, all right then. I had been intending to wait until 1:30, but I'm happy to be guided by you. I'm sure you've got a better sense of what participants would like. So let me simply introduce Louis Reitmann. Louis is the Export Control Support Officer at Imperial College, London. Today, Louis will explain the importance of export controls in academia, and he will analyze current compliance shortcomings in the United Kingdom. Looking forward to hearing from you, Louis.
Thanks very much, Peter. Give me just one moment to try and share my screen with you. Can you see that okay? Yes?
Yes.
Yes, lovely. Right, so thanks very much to British Pugwash for this opportunity, and I'm so sorry to have to rudely interrupt the excellent questions and answers on these very interesting other two topics. But I would like to talk to you about, as I see it, the hottest topic on the UK non-proliferation agenda. Perhaps I'm a bit biased, but through my presentation, I hope to convince you too of the great importance of export controls in academia. I'll be arguing that export control compliance in the sector is poor. I'll explain why that is, and I'll present some steps that universities and the government can take to better protect against proliferation risk. So hopefully I can stir your curiosity. But beforehand, just a quick disclaimer that I'm not speaking on behalf of Imperial College London, and that any observations and opinions that I'll be sharing with you today are exclusively my own. And to get going, I want to give a quick explanation of what export controls are and how they work for those of you who might not be familiar with them. So very simply stated, they are laws that restrict the transfer of sensitive goods, software, and technology by any means to recipients outside the UK. And the way that they work is in two main paths. One is that the government publishes the strategic export control lists. They're mostly derived from international non-proliferation regimes like the Chemical Weapons Convention, the Australia Group, and so on. And these lists are largely made up of the military list, controlling everything made specifically for military use. Think weapons, explosives, target tracking technology, and the dual use list, controlling items with civil and military applications like avionics systems, advanced materials, pathogens, and such things. And secondly, there are catch-all controls on certain end uses. That means that any item, whether on the control lists or not, is controlled if it's going to be used for military or WMD purposes, and increasingly for human rights violations as well. So in short, anyone in the UK who wants to export anything on the control lists or anything for prescribed end users to anyone outside the UK needs an export license, which is issued by the Export Control Joint Unit in the Department for International Trade. If you have more questions about how export controls work, I'm happy to answer them later on. But for the moment, let's look at what that actually means for universities. What are the implications here? So as everyone in the UK, universities must comply with export controls. However, for them, this comes with immense challenges. And let's look at some of those. Let's look at some of the things that universities need to do for good compliance. First, you need a complete overview of the exports that every researcher makes to be able to check whether export controls apply to any of them. Now, that's much easier if you're a company selling physical goods to overseas customers, but universities are much more devolved, and there's no central overview of the activities of researchers who, under academic freedom, are encouraged to be free-spirited, entrepreneurial, and such things. And you also face the problem that about 90% of exports at universities are intangible transfers of knowledge. They are emails, calls, meetings, exchanging data with overseas colleagues. Of course, you also need to train your staff, and you need to have someone on hand to answer questions about export controls. So you have to hire enough export controls experts like myself to support the thousands of researchers that you employ. On top of that, researchers themselves need to become experts in knowing whether any of their research is captured on the 300 pages of the control lists. And very importantly, you have to build capacities to actually vet your funders and your collaborators for proliferation risk. You need to be able to do research on the people giving you money and the people that you will be working with. But there's also there are also many other perhaps less obvious things that you need to be thinking about. For example, the fact that it's not just research. You must also ensure that export controls are followed during online classes, conferences, CPD courses, and by students completing internships overseas. And you're even legally obliged to record every single export made. So looking at all these challenges, it's perhaps unsurprising that I find that export control compliance in universities has been poor. But the key point is that this is concerning because universities are some of the biggest innovators and exporters in dual-use technology. This is why I call them the front line of non-proliferation. You see, even before parts, products, physical things, which could contribute to the proliferation of weapons, are made by companies and then shipped to countries of proliferation concern or countries with porous borders from which they travel onwards. Universities will be sharing the technology and the know-how to develop and make these items with their partners all around the globe. So the proliferation through universities can have just as serious consequences as arms trade, for example. Large research-intensive universities have thousands of projects, most involving overseas partners, in dozens of disciplines at any one time. So there's a massive volume of things that could potentially be controlled, that could potentially pose proliferation risks. And through insufficient compliance, some of these technologies can end up being misused. And I want to give you some concrete examples. The development of new ways to weld together commercial airplane parts to make them safer could also be used to increase the life cycle of a fighter jet. And the software to improve the navigation of drones for the delivery options of tomorrow can be misused in military drones sold to Libya and Saudi Arabia. Even research that aims to track the spread of disinformation around voter fraud in the US, for example, can be misused by authoritarian regimes to persecute their opponents. And there are, of course, those technologies like machine learning, which are so nascent that we can't yet really predict how and by whom they could be misused. Often those technologies aren't even controlled because the legislation just hasn't kept up with them. So now that we know what the problem is and the scale of the probabilities are lagging behind in export control compliance, and there are a few reasons that are linked directly to how universities work and how they're set up, and there are a few reasons that relate to what the government has or hasn't been doing. But let's look at those related to universities first. We know that universities must be places of international collaboration, but inevitably this openness by design leads to blind spots for proliferation risks. If, as an academic, you have been told for all your career that your career depends on collaborating and publishing as internationally as possible, you won't be approaching your overseas partners with the scrutiny that sometimes you need to. And that brings me to the next point, which is that universities face tough competition. Competition for funding, citations, students, researchers, etc. And this means that the university will find it difficult to be a trailblazer in something that could actually disadvantage its researchers, its revenue, its competitiveness. Universities aren't incentivized to spend more money on compliance functions, which might actually halt some of their research projects by applying export controls. And this affects their risk assessments on the inside. Without people whose only job it is to be risk aware, you end up with academics assessing the risks themselves, even though they have quite obvious conflicts of interest. And thirdly, many universities, Oxford and Cambridge, for example, with their colleges, but also Imperial, are devolved and decentralized. Every department has its own culture, organization, and personalities. Some are more receptive to export controls, others are more resistant. And even within departments, there's often no comprehensive overview of what researchers are doing. And that means that you essentially depend on those researchers to flag where controls might apply, which is not their priority and not what they're hired to do, frankly. So there's that. And let's now turn to 3 more reasons on the government side. For many years, the government had made very little effort to raise awareness for export controls in UK universities. And now that Whitehall is beginning to target universities, when you speak to researchers, most assume that this is brand new legislation, even though the Export Control Act has been around since 2002. So that really goes to show that there was very little effort made to inform them about this. Especially, and this is kind of the elephant in the room, cooperation with China was encouraged by previous governments, but with the geopolitical situation changing, long-standing projects are being terminated because the government won't issue export licenses, albeit for good reasons. Still, this causes significant losses for universities, and it could have been avoided had the government warned universities earlier on of this shift and allowed them to diversify away from China. If this feels like an unfairly sudden cost on universities, that's because it is. So that would have been this point. And finally, oh, pardon me, no, we're actually right there. Universities drive to secure funding from overseas, in part, is because public funding from the UK and Europe is not sufficient in all subjects. This is also why universities recruit more overseas students, especially from China, charging them more than double the fees than home students, which in turn comes with some downside risks. Some Chinese Mint subject graduates go on to work for some of the most notorious Chinese proliferators of military and WMD items using the skills that they acquired in the UK. And the final reason I want to mention to you is that academia is not industry. And sometimes it feels like that's academia's fault. UK export controls, from the legislation down to the application forms online, are designed with large companies selling physical goods in mind. And because companies like Rolls-Royce and BAE have long been the main audience for export controls, because they have invested in compliance and because they frankly make a bigger contribution to the balance sheet of UK PLC, the system prioritizes them. And it's also much easier to process licenses for discrete products than licenses for intangible knowledge. But fortunately, the government is beginning to realize that these companies aren't necessarily the exporters with the biggest proliferation risk. And finally, let me point out some measures, some achievable, mostly operational changes that would go a long way to better safeguard British research from misuse. Let's first look at what the government would be able to do. The first thing is to boost the ECJU's resources. This is a small unit with few resources that has trouble processing those complex applications from academia in a reasonable time, not to mention the flood of applications they would receive if universities stepped up their compliance. The ECJU also needs more and different experts to process applications from all scientific disciplines. And, you know, the bottom line there is, if the government wants universities to be compliant, then the ECJU needs to be able to complete its part of the process as well. The second measure could be time limits on applications. At the moment, the ECJU can take as much time as it needs for an application, mainly to be able to collect all the open and classified information on end users that it needs. But what pains universities more than having to terminate projects because the ECJU refused to license is having to terminate a project because they received no answer, despite waiting for a year or longer. This frustrates researchers immensely, and it damages their relationships with their overseas partners. It's also altogether not a great look for the UK. The ECJU could introduce a time limit after which an application is automatically refused, and the new National Security and Infrastructure Act already has those similar time limits. Thirdly, applications need to become more intuitive, more suited to academia, and there needs to be accessible training. The reasoning behind this is that universities simply don't have the money or the organizational design to handle export controls centrally. That means the researchers themselves must be able to navigate the export control process. And if they're going to do this, the entire process must become more intuitive, more considerate of their needs, and there must be easy to understand training available. And what will help the government to do exactly this is to listen and to better understand what impact export controls have on research and teaching. They need to listen to exactly those challenges I talked to you about in the beginning that universities face. And finally, let's look at what universities might be able to do. Foster culture change. Just as universities have encouraged researchers to be open and collaborative, they need to condition their researchers to carefully assess whether their work could be misused. What's most important for export control compliance is really not an efficient or centralized process. It's that every researcher is equipped with the mindset to critically question who they work with. And that doesn't come natural to them because they're used to thinking about the positive opportunities that come with their research. Secondly, as I've already said in the beginning, one of the things universities need to do is raise awareness, train, develop processes and helplines internally for university researchers to turn to when they have to worry about export controls. Fortunately, this is largely happening across the sector. Most universities are beginning to hire people like me to do this work, but a lot more needs to be done. And there could indeed be centralized export control assessments for some high-risk departments or groups. So while you can't implement this across an entire university because it's simply too much money that you would need to spend and too much reorganization you would need to do, for those high-risk departments like aerospace or those working on advanced materials, for example, that have a high risk of being misused for military and WMD purposes, you could direct every project that they work on with overseas partners through a centralized assessment process. And the very last point, when you do those risk assessments of whether there are proliferation risks associated with certain partners, or whether certain projects might be sensitive, whether anything of that project might get used for prescribed purposes abroad, you need to have a balanced risk assessment. You cannot have the researcher who is interested in getting this project on the way up and running, complete the risk assessment and make the decision on whether this project goes ahead or not themselves. You need to have those people on the inside whose only job it is to worry about these risks to give a balanced assessment. So that was quite a lot, but I'll stop there and happy to answer any questions.
Thank you very much, Louis. A third excellent presentation. I'm going to butt in to put 3 quick questions to you. Do the export control lists specify individual bits of know-how, individual bits of intangible knowledge that are subject to export controls? I always imagined they simply specified hardware implements, I mean objects. I didn't realize they went into the intangible sphere. Secondly, have you a rough idea of how much the British universities, British academia as a whole? Can you hear me?
Yes, I can hear you fine.
How much British academia as a whole exports or was exporting anyway until, should we say, 2018, 2019, when relations with China began to become more problematic? And thirdly, have you made all the points which formed the last part of your presentation? Have you actually put those to government or to representatives of government?
Excellent questions. So on the first, the lists have very large parts of physical items that they designate. So you'll have a part on a certain test equipment, a part on nuclear materials, and so on. And at the end of every chapter, if you will, there's a category on technology and a category on software. And the particularly tricky bit about these categories is that they'll just say any technology, any know-how, any software that is necessary for the use, development, production, maintenance, repair of the items that have gone before are controlled. And that makes it difficult for universities who are often involved with technology that is quite fundamental to know whether their technology counts under these controls. So an example would be you might help a company overseas rethink the way that they produce silicon wafers used in IT equipment. Now, the university in the UK might only do very basic research on this. How does the silicon behave under pressure and heat? The technology that comes from this isn't ready to be used in a manufacturing plant, but it will inform how the overseas company will adjust their manufacturing process. So it's difficult to know, does this already constitute technology or not? On your, please remind me of the
value
question.
of these kind of university, of the total university exports of this kind?
No, I'm afraid there's no number like this.
No figures, no statistics. That doesn't surprise me.
No, it's tough enough for universities to know how much they're exporting, where and from where internally. Yeah,
and the third one was to ask whether you've discussed all of this with representatives of government and put your points to them.
So I can only stress again that this that all that I'm saying is in a private capacity, and that there is a concerted effort by some of the leading universities in the UK, including Imperial College, Edinburgh, Cambridge, and many others, forming a nationwide association that will coordinate export controls in academia with the government. So there's essentially a lobbying group, an association being set up that will help universities become better at export controls, but it'll also talk to the government about the challenges that universities face because they are quite different from industry. And in those forums, I hope that these points will be discussed.
As someone who once worked in government, I thoroughly urge and encourage you to go down that track. I think the points you made seem to me extremely reasonable, and it's very important that government be acquainted with them. Sorry,
Well,
Ludovica, sorry to have taken over, but back to you.
All right, we just have a question from Talia Weiss. It's for Harry. Could a reasonable amount of money and R&D fix the problems with US missile defense systems, or is that unrealistic because consistent missile defense is so technically difficult and because improvements to defenses would prompt increased efforts to thwart them?
Yeah, brilliant. So Talia, that's a brilliant question. And it's a question that's basically been asked in the United States long before I was born. And there's a question that's still circulating policy circles. I like that you put a reasonable amount of money in brackets, because, you know, I think that really hammers home that how much people are willing to spend on missile defense systems really depends who you're asking. I think if you took a missile defense skeptic, let's say like Theodore Postel, and you put them in a room with a representative from a big defense contractor, they're probably not going to see much agreement. But if I can give you a short answer, yes, actually money and research and development can fix some of these technical issues. But there are some issues, and I mentioned this in the paper that Peter brought up that we put out in November. So if you are interested, I do encourage you to read that. But there are some issues that money and, you know, the technical sophistication of the system in question simply will not be able to fix. So some examples, so better discrimination capabilities. It's, you know, like these systems have gotten better at discriminating what is a warhead, what isn't. You can improve the strength of the radar so they can track more objects. So when, let's say, a theater missile defense system is operating in a combat zone and there's aircraft going everywhere and there's rockets flying everywhere, the radar doesn't get saturated and it doesn't stop working because it reaches a specific limit. You can improve the interceptor itself with money and R&D, so you can change its capabilities, the altitudes at which it works. Lockheed Martin are currently working with their partners on something called the glide phase interceptor, which is like a variation of the SM-6 missile, which is now designed to operate at the kind of specific altitudes and conditions at which hypersonic glide vehicles are operating. There's been no tests on it yet, but we're expecting some soon. And you know, in like the really baseline ways, you can just buy more interceptors. You know, you can buy more interceptors, you can buy more batteries, and some systems like the IISS system, to guarantee a kill, the kind of strategy is to always shoot twice. So, you know, by default, if an enemy fires 100 missiles at you, you're going to need, if you're employing that strategy, you're going to need 200 interceptors as a bare minimum, or you're going to start suffering trade-offs. But that said, there are a lot of issues that money will never be able to fix. Money will never stop cruise missiles being able to maneuver. Land attack cruise missiles can utilize the terrain to arrive at their targets and reduce reaction time. Radar background disruption. Again, if a projectile is flying towards you and you're using like a short-range air defense system, this was particularly a problem in the Falklands conflict. Trying to distinguish that cruise missile from everything going on behind it is very, very difficult to do. And there's something, you know, that's just an inherent limitation of certain types of radar. Weather, X-band radar is the same radar that we use to measure weather. But is also some of the types of radar that's used in missile detection and tracking systems. Money's never going to be able to fix the weather as much as I'm sure us in the UK would like it to. And the last is that attacking will always be cheaper than defending. You know, so some of the operations that Iron Dome's been in 2014, I read a paper for the Pugwash research. And it really drew attention to the fact that, you know, Iron Dome batteries are $50 million. And they're used to shoot down projectiles that are at times so cheap they can be made in people's homes, or they can be made in garages or workshops. So there's a real disparity between the fact that you're firing $100,000 and $150,000 interceptor at something that's been made for a few $100s. And that's just something you will never be able to overcome. No system, no matter how good it is ever going to be able to overcome the financial problems with deploying missile defense. It depends how deep your pocket is, really. But yeah, brilliant question. Yeah, big question.
Do you have any other questions, Ludovica?
I cannot see any other question.
If I may, then I will put a question to Harry. Harry, what struck me was the stark contrast between the standoff between the United States and China in the Pacific theater and the Cold War standoff between the United States and Russia in Europe. In Europe, the United States and Russia had an incentive not to be the first to initiate conflict. The situation you described so graphically and so clearly and so well is one in which, as you put it, the United States and China each have an incentive to be the first to initiate conflict. This is seriously worrying, isn't it?
Yeah, I mean, it's a brilliant question because I always find this question of drawing comparison between, you know, the nature of the Cold War and the new Cold War, or the relationship between the US and China is interesting because, you know, there's comparative similarities and there's also big differences. I think one of the main things to remember about what I say when I say strike first doesn't mean that these two countries aren't hunting for war, right? These two countries I'm not, when I say that they have an incentive to strike first, this isn't meaning they're actively hunting for catalysts to start a war with each other. I don't believe that the United States and China are destined to engage in a conflict in the near future. I think there's certain flashpoints where that will happen, but they're by no means, you know, looking for it. But the problem is, and this is very much my own take on it, and I'm welcome to any challenges on it. The difference between conflict with the United States and the Soviet Union was that it was always 100% of the time inherently going to take place under the guise of nuclear weapons. Whereas that is not always the case with the relationship between the US and China. There are that area between what will become a nuclear war and what stays a conventional war is very, very blurred. And that's for a number of reasons. You know, there's a bigger taboo about the possession and use of nuclear weapons. There's an incentive in these kind of regional conflicts not to use nuclear weapons. And there's also a deterrence effect from the fact that you don't always know what is going to be a nuclear weapon, what isn't, especially with the Chinese stockpile, and that's often done by design. So yeah, and I think you hit the nail on the head. That is worrying. The fact that and this came up in a conversation not too long ago with some other colleagues in a call, that there is a kind of complacency about the fact that, yeah, you know, we're back to conventional war now. Nuclear threat isn't a problem. We can potentially go to war over these contingencies without too much of a worry of nuclear exchange. And that's something maybe I should have mentioned in the presentation, that all these strategies, when I say escalation, that means a real possibility to escalate to the nuclear threshold. Not necessarily, in my opinion, instantly, but it depends on what's hit. You know, and this is an ongoing problem. The Third Nuclear Age have worked on this as well, about this kind of entanglement issue. James Acton wrote a brilliant paper on it about, you know, the increasing tendency for so many pieces of military hardware to have nuclear relevance. And that's everything from radar, communications infrastructure, even, you know, the types of missiles. You don't know what it's carrying until it lands. So, you know, sometimes do you wait until it detonates, or do you just assume that it's a nuclear exchange? We don't know. And we don't. And the scariest thing is we'll probably only find out until the rocks start flying. But I can't really say more than that. So.
Right. Well, let's hope this doesn't turn into a case of you heard it here first. Ludovica, is that it then, do you think?
Yeah, I think you can give our conclusive remarks.
Yes, well, I haven't got a lot to say, but what I do have to say is very important, because I first of all want to thank the three of you, Louis and Harry and Fabian. Thank you once more for your presentations. I can't do better than describe them as excellent. They were really, all three of them, extremely interesting, extremely stimulating, very, very worth listening to. I also want to thank you, Ludovica, for helping me out with the questions and answers. I want to thank all our participants today who, by participating, have helped to animate this event. I hope you've all enjoyed the event and have found the discussions, the question and answer sessions and the presentations stimulating. Can I just say that I also hope that if any of you are not already members of UK Student Young Pugwash, today will have inspired you to join. Until you're 30, I think I'm right in saying until you're 30, it won't cost you anything. And we'd very much like to have you with us as part of our organization. And last but not least, certainly not least, I would like to thank Andrew Gibson, to whom the Committee of British Pugwash is deeply indebted for the organization of these annual conferences, and for all the hard work that he puts in year-round into running Student Young Pugwash. He too does an excellent job. So I think that's it, unless anyone wants to say anything. No reason why you should. Can I declare the meeting closed then?